Hello everyone. Today's class is going to review the answers for test number 2, and I hope everyone has already taken this test and have a satisfying grade. So let me just open up these slides in a PowerPoint where I can write down my annotations, and let's just get started. Okay, so we have 28 questions, and most of them are calculations. Because in the final exam, we're going to have a bunch of calculations as well. And so we want to have everything practiced in either homework or the tests. And if you see some problems, the type of problems repeated both in homework and in tests, that means this type of problem is very important, and highly possibly it's gonna be appear again in the final exam. Okay, so question number 1 is about simple interest. So 2,000 is borrowed at an annual interest rate of 15% for 10 years, and this is simple interest, which means the interest is only based on the initial principal. Okay, nothing about the interest earned per interest period. And so based on the statement, what are the correct values for the initial principal, the interest rate, and the number of periods n? Okay, you see here we didn't ask number of years. We always ask a number of interest periods, because interest periods could be months, 3 months, half year, or a year. Okay, it's not necessary to be just a year or number of years. And this is very important concept. Number of interest periods. Okay, so what is the principal? It is 2,000. Okay, so P is 2,000. And what is the interest rate? It said it's 15% per year, okay, because it's annual interest rate, right? So which means it's per year. So I is 15%. And the number of interest period, because it's compounded per year, so number of years is number of interest periods. Okay, so it's 10. So 2015 and 10. Based on this statement in question 1, what is the total interest I? Which equation to use? Okay, so this is very easy. The simple interest formula for I is P N N I. So that's gonna be this one. I think there is a typo in the options. So the GA who is digitizing this testing for me forgot to change this to the lowercase I. Also, this one should be lowercase I, and this should be lowercase I. Okay, so this is the typo he made. And based on the statement in question 1, what is the value of the total interest? So if you selected the right formula, I equals to Pn and lowercase I, you just substitute the letters with the numbers 2000, 10, and 15. And what you have is gonna be 3,000. Okay, so this is your answer. That's your interest earned. during the past 10 years. And what is the total payback for question number 4? Total payback should be P plus I, principal plus the interest. So 2,000 plus 3,000, that is 5,000. Another question, it's basically the same numbers, but it's compounded interest, okay? It's not simple interest, and it's compounded annually. So principal is still 2,000, and interest rate is still 15% because it's compounded yearly. So the yearly annual interest rate is going to be the right interest rate used. And then number of interest periods, again, it's compounded yearly, so it's number of years. So N is 10. Okay, and so it's 2015 and 10. And what is the formula for compounded interest? It should be this one. Okay, and so if you chose the correct formula, that interest will be P times 1 plus I to the power of M minus P. And you substitute the letters with the numbers. 2,000, 1 plus 15% to the power of 10 minus 2,000. That will give you the answer of, let me see. $60.91.12. And the total payback is still P plus I, which is 2,000 plus 6091.12. So it is $80.91.12. A new question. Which statement about simple interest and compound interest is correct? Okay, so by definition, simple interest is the interest per period, which is always charged only on the principal. So nothing about the interest earned per period. But on the contrary, compound interest is the interest per period, which is charged on the principal plus any accumulated interest. It's like rolling a snowball. It's gonna be bigger and bigger because every time you're gonna have a new size of a bigger snowball, have a basement as a basement, right? So that's compound interest, and this one is your correct answer. And question number 10, 1,000 is borrowed at an annual interest rate of 10% for 5 years. But interest is compounded every 3 months. Okay, this information is very important. It tells you the compounding period is every 3 months. According to this problem, what is the statement about number of interest period, interest rate per period, and interest period? That's 3 concepts. What are the correct numbers of them? So number of interest period, you need to know what is the interest period is. So because the interest is compounded every 3 months, so every year it's compounded 4 times. Okay? So for 5 years, 5 times 4, that's the number of interest period. So the interest period is 20. Interest rate per period. Because it's compounded per quarter, every 3 months. Okay? So you need to use the annual interest rate of 10 divided by 4. That is 2.5%. So that is your interest rate per 3 months. And interest period is a quarter, or you can say 3 months. So it's 22.5 and a quarter. Based on this question, what is the interest after 5 years? Okay, so for this question, you can use the factor method. That's the future equivalent of this 1,000 after 5 years. Or another option is you can use the formula of compounding interest rate, of compounding interest. Okay, so what I used is the formula of compound interest, which is I equals to P times 1 plus I to the power of n minus P. So P is 1,000. I is 2.5%. Number of n is 20 minus 1,000. And your answer is 638.62. Okay. Okay, I think I made a mistake about saying you can use a factor method to calculate the interest. Actually, the interest is going to be calculated using this formula. You cannot use a factor method because factor method is to find the future present worth. Okay, and the future present worth is actually your total payback, but well, that's complicated. So let's just stick with this formula to calculate interest for compounding interest problem. Okay, another question. If 2,000 was borrowed from the bank by Tom at the beginning for 6 months at 5% interest rate compounded every month, Tom paid 200 at the end of every month. What is the correct cash flow diagram? From whose viewpoint? From the bank's viewpoint. From the bank's viewpoint, think about that. The bank is lending money to Tom. So it's the 2,000 is at the beginning is out of the bank's pocket, right? So it's outgoing cash flow. It's going downward. I mean, the arrow of 2,000 is going downward. So at the beginning, you have this 2,000 going downward. And how many months? You have 6 months, right? So 1, 2, 3, 4, 5, 6. And Tom paid 200 at the end of every month. So the 200 from the bank's perspective, it's a receiving every month. So it's arrows going upward, and because it's happening at the end of every month, so that's an annuity of 200, and the interest rate is 5%. Okay, so which means this one is your correct answer. Suppose that you borrow 5,000 now. Okay, you borrow 5,000. This is a new question. Promising to repay the loan principal plus accumulated interest in 5 years at interest rate is 10% per year. How much would you repay at the end of the 5 years? Okay, so that's equals to ask you what is the future equivalent of the 5,000. Okay, So it's to convert a present worth to a future worth. To do that, the formula is what? F equals to P times, to find the F slash P, I% and N, right? And here, if you need to use a factor method, which formula to use? We just wrote it down, right? And then you just need to find out what is I and what is N. I is, there is no statement about a different way to compound, a different frequency to compound. So which means it's compounded every year. So the I equals to 10%. That's per year. And N is number of years, because you have 5 years, so it's 5. So it's gonna be P times F slash P, 10% and 5. And based on this formula, what is the repay at the end of the 5th year? You just substitute the letters with the numbers, and also check the factor in the table in Appendix C. So this is 5,000 times, what is the factor? The factor is 1.6105. So your final answer is 8052.5. That's the future equivalent of this present 5,000. Okay, a new question. You borrow 20,000 from your credit union to purchase a used car. The interest rate on your loan is 0.25% per month, and you will make a total of 40 monthly payments. Okay, so the rate is per month, and you're gonna make monthly payment. Sounds like your interest period is 1 month. So what is your monthly payment? Okay, and so this is a problem to ask you what is your annuity, what is your monthly payment, because every month you're gonna pay the same amount. So that is an annuity. So this is to find the annuity given a present value. The present value is the 20,000 you borrowed. Okay, so the formula is gonna be to find A from given P. So it's gonna be P times A slash P, I% and N. Okay, and I, because it's already told by per month. Okay, so that 0.25% is gonna be your I. And N is number of months. So it's 40 months. So it's gonna be P times A slash P, 0.25% and 40. So you just need to substitute the letters with the numbers. So P is 20,000 times the factor of A slash P in the table of 0.25%, and number of periods is 40. So that factor is gonna be, if you check the table, it's 0.0263. That is 526. Okay. Question 17. What is the present equivalent value of the cash flows shown in the following diagram? This is a multiple cash flow problem. Okay, and I also use different colors to draw different types of cash flows to give you a hint. So first you need to decide how many parts do you have. how many different cash flows do you have. Okay, so this is your part 1, and the annuities is your part 2, and this future value is the part 3. So you have 3 parts to convert back to the present value. So if you're looking for present value, P0 means the value at the time 0. It has 3 parts, P1, P2, P3, okay? And P1 is the 1,000, P2 is the annuity of 15,000 per period, and P3 is the negative 800 at the end of the 6th year. Okay, so P1 is the 1,000, P2 is from, so you need to convert P to P. P2 is from the annuity of 1,500, so it's to convert annuity to present. P3 is from the negative 800 at the end of the 6th year, so it's to convert a future cash flow to present cash flow. Okay, so your P0 is gonna be the sum of all of this. So first, P1 is already a present worth, so you don't have to convert. So just write it down, it's positive 1,000, and plus annuity is also in this diagram, it's a positive cash flow, so it's positive. And you need to convert the annuity to the present worth. So the formula is gonna be the A times P slash A, 10%, number of years, 6. And then you need to have a negative cash flow at the end of the 6th year. That's your part 3. It's to convert a future cash flow to the present worth. So the formula is F times P slash F, 10%, 6. So now you just need to calculate. A is 1,500, and this factor, you need to just check it out. It's 4.3533, and minus 800 times that factor is 0.5645. So the answer of this question is gonna be 70, 78, 35. Okay, question 18. If it is said that the nominal rate is 10% compounded semi-annually, okay? Nominal rate is 10%. It's always annual interest rate. So, but it's compounded semi-annually. So it's compounded every half year. So every year is compounded twice. The interest rate per compounding period is gonna be what? Per compounding period means per half year. So interest rate per half year is 10% divided by 2, so it's 5%. And one compounding period is, because it's compounded semi-annually, so it's half year. Every year it is compounded how many times? 2 times. So it's 5%, half year, and 2 times. New question. Suppose that 1,000 was invested as a principal for 5 years at a nominal interest rate of 20%, compounded semi-annually. Okay? Always look for this information. That's the specific frequency of the compounding. So what is the effective annual interest rate? We have learned a formula to calculate the effective annual interest rate. And so this problem is very easy. That's the formula. But to get the answer correctly, you need to determine what is R, what is M. Okay? R, by definition, it is the nominal annual interest rate. So it's 20%. But M is number of interest periods because it's compounded every half year. So for every year, it's compounded twice. So for the total of 5 years, it's compounded how many times? 5 times 2, which is 10. So you just substitute these new values into this formula. So your effective annual interest rate is 1 plus 20% divided by 10 to the power of 10 minus 1. Oh, wait a second. The M is the number of interest periods per year. Okay, so it is not 10. Okay, so M is number of how many times compounded per year? It's 2 because it's compounded semi-annually. Okay, so here in the formula, this is gonna be 2 and this is 2 as well. Okay, so that will give you the answer as 0.21. So that is 21%. Okay, this is a new problem. A piece of new equipment has been proposed to a company to increase the productivity of its manufacturing line. Okay, so this is one single project. And you're going to decide if it's a sound project or not. The investment cost is 30,000. That's initial investment. And the equipment will have a market value of 6,000 at the end of a study period of 6 years. So increased profit attribute to the equipment will amount to 9,000 per year after extra operating costs have been subtracted from the revenue generated by the additional production, which means the 9,000 is your pure receiving. Okay, it's a net income. If the firm's MAR is 25% per year, is this proposal a sound one? Okay, so first thing you need to draw the diagram, and we have 4 options. So we said the point of view you're going to use is the company's perspective. Okay, so the company needs to spend 30,000 at the beginning. So the 30,000 is going to be the arrow going downward. So this is going to be wrong. And you're going to choose from the next 3. So, and every year you're going to receive 9,000 as your profit. So it's 9,000 going upward. And don't forget about the 6,000 market value, which is also positive. So this one is going to be the right answer. And based on this diagram, what is the value of the present worth of all the cash flows? So this is also a multiple cash flow problem, right? You just need to convert the 3 parts, this present value, this positive annuity, and this positive future value back to the present time. Okay, so you need to write down on your scratch paper, you have to calculate the P0, and it has 3 parts. The first part is from the negative 30,000 present worth, and it's to convert P to P, right? The second part is from the positive annuities of 9,000 every year, is to convert the A to P. And the last part is from the positive 6,000 at the end, and it's to convert future value to present value. Okay, so your P0 is the sum of all of this. First, you just need to write down the 30,000 because it's already present worth. And then you need to use the formula to convert the annuity to present worth, which is A times P slash A. Number interest period is 25%. Number of periods is 6. And then you don't forget about the 6,000 future cash flow to the present. So use the formula of F times, look for P given F, 25% and 6. Okay, and then you just need to substitute the letters with the numbers. So 30,000, still 30,000 negative. A is 9,000. The factor of P slash A, 25%, 6. Is 2.9514. And F, the future value is 6,000. And then the factor is 0.2621. So your final answer is negative 1864.8. It's negative, which means you are gonna lose this amount of money if you accept this proposal. Okay, so it is not a sound one. So this is your correct answer. All right, the next question is about the bond value. So to calculate the bond price, we have a formula, straightforward, okay? Just use the formula, but you need to determine the right values for those letters, the C, the I, the N, the R, the Z, okay? So C is the redemption, which means that's the price, that's the amount the bond issue, the bond company will give you at the end, okay? And usually C is the same as the face value. So let's just read through this statement. Assume that you are considering purchasing a certain U.S. Treasury bond that matures in 10 years, okay? That is number of years, and has a face value of 15,000. Face value is Z. This means that you will receive 15,000 cash when the bond's maturity date is reached. So this is C. The bond stipulates a fixed nominal interest rate of 8% per year. Be careful, it's per year. But interest payments are made to the bondholder every 3 months, which means it's compounded every 3 months. Okay, which means it's compounded how many times a year? 4 times a year. So therefore, each payment amount is 2% of the face value. Actually, it's already told you that it's 2% every 3 months. That's the R. If not, you still can calculate using the 8% divided by 2 divided by 4 because it's compounded 4 times a year. Let's say you would like to earn 12% nominal interest rate, which is annual interest rate, okay? So 12% is your MARR per year, but what is your yield rate per quarter? It's gonna be 12% divided by 4, which is the 3%. Okay, so that is your I. So, and what is the number of interest periods? Because in 10 years, you're gonna have how many quarters? It's 10 times 4, which is 40. Okay, so n is 40. All right, so your correct answer is gonna be this one. And then you just need to substitute the letters with the numbers, okay? And then your final answer is gonna be this one. All right, this is the last problem. It's two projects. You want to compare which one is better. So the method is you can convert everything back to present worth and then compare which present worth is bigger. If it's a investment problem, you just need to see which value is bigger. If it's a cost problem, you just need to choose the less negative one. Which one has the PW as a less negative. Okay, and so the cash flow is given in the table, and then the first thing is you need to translate that into a cash flow diagram. So the alternative A, at the beginning, which means the time 0, you're gonna spend 35,000, okay, because it's negative. And for year 1, year 2, year 3, and year 4, at the end of every year, you're gonna spend another 3,000. Oh, it looks like all the cash flows are negative, which means it's a cost problem. Okay, so you might have two negative present worth at the end, and you want to choose the less negative one as the better solution. All right, so let's see what is the correct one for alternative A, the diagram. So you have how many years? 4 years. So 0, 1, 2, 3, 4. And at the beginning, you have the negative 35,000. And every year, you're going to spend 3,000. So that's annuity of 3,000 going downward, okay? So your correct answer is gonna be this one. And then you're gonna check the alternative B. Still, alternative B, you have negative cash flows, but at the end of the 4th year, you're gonna have a positive cash flow of 5,000. That might be the market value if you sell this equipment or sell your project. So yes, this one is correct as well. So this is your correct answer. And then you're gonna calculate the present worth based on these diagrams. Okay, so and for each one, it's a multiple cash flow problem. So you have two parts for each of them. This is your part 1. This is your part 2. So part 1 is to convert P to P. Part 2 is to convert A to P. Okay, and they're all negative. And the same thing for the second option. You have 3 parts. Part 1 is to convert P to P. Part 2 is to convert A to P. Part 3 is to convert F to P. Okay? So if you write down the P0, for alternative A, you're gonna have negative 35,000 at the beginning, and then you're gonna have negative annuities converted to the present value. So the formula is A times P slash A, 10% and 4, okay? And A is 3,000. The factor is 3.1699. So the answer is negative 44,509.7. And about alternative B, the same thing, you have 45,000 negative cash flow at the beginning, It's present worth already, so you don't have to convert. And then you have negative annuity to convert to the present worth using the same formula, A times P slash A, 10% and 4. And don't forget about the 5,000, okay? Let me just erase this so you don't confuse. So plus a future value, the formula, and the P slash F, 10% and 4. Okay, and then if you calculate, this is gonna be, the final answer is gonna be negative 49,509.75. Okay, and then you just need to compare which one is less negative. Of course, this one is less negative, so A is your choice. So you just need to choose the answer, and then alternative A is better because it's less negative. All right, so that's it. So I will see you